So as a continuation from the previous class that we had, remember we managed to work with the area whereby we are just having a single or just one curve or a function that we are given let's say we are given y is equal to f of x like what we had previously. And this function that we are given is being taken between 2 points, like the limits which are going to be applied or to be used are taken between the 2 points, which is A and B. All right. So we had that from the previous concept, guys. We had that we are going to simply consider the strip that is the one affecting the limits that we have. These limits are for what? Which axis are we having for these limits? They are affecting the x-axis. So the limits that you have here are the ones that are going to affect your representative strip, meaning to say, according to this case, our representative strip is going to be for what? For x. These limits are for x. We are in the x-axis. This is the value for x, the value for x. If it was that the limits were for the y-axis, the limits are the ones that you're supposed to consider. So if you just consider this, guys, you are done. If your function is they're like this, it means you're referring C and D, but what are we going to have as for this strip? These limits are in the y-axis, so this is the representative strip for y. Okay, so we had that part, guys, and we managed to calculate or to determine our areas differently, depending with what you be given in form of the diagram, which is the graph that you're going to have at the end. All right, so in our case, we are saying we need areas bounded between two curves. We have two graphs. There is a function and another function that we are given. So I'm just going to explain as of the limits, which are for the x-axis and which is the representative strip being for the x. So guys, it's just going to be the same for the y. So not going to waste much time there. So let's say we are given two functions or two graphs, right? The first one is being drawn. Let's say this is a parabola that we are given. Y is equal to f of x, a parabola. Then another one is being drawn. Maybe it's a straight line, whatever that you're given. Maybe it's an exponential function. But there is another function which is being drawn. Let's say it's a straight line. Or maybe it is an exponential function like this, whatever that you be given. These two functions that we have, they form a certain region bounded by these two functions. So where the region is on this region here, you consider to say which of the two graphs is on top and which one is below. Look at this function as we are moving here from this point up to this point here. This function or this graph that we're having is below this one because this is on top. When you say to be on top, that's above. To say there's a line like this, there's a curve like this. This one is above, on top. This one is below. So in our case, from where these two are intersecting or from where the area is to be calculated, which is on the points between the points of intersection of the two graphs, where they are intersecting, as you can see, there's an area which is bounded there. So consider to say which graph is on top. This one, it is the one that is above. It is on top of which? Of this one. So the one that is on top, we are going to call it y1. So that is why here I was not writing my functions to say this is y what. I just draw my function. So we are going to call the one on top. y1. And the one which is below, we are going to call it y2. So we must have something on top, something below. So this is the function which we are finding or which we have on top. And this is the one that we have below or on the bottom. All right. So this is our case. There are two functions there. The one is on top, the one is below. On that region alone. Because if you consider, guys, if you just move from there, from this point of intersection, if you just move aside here, you'll see that this function now is on top. This one is below. Look where it is going. It is now below. It is on the bottom now. So you don't consider other regions. You only consider the region where the area is to be calculated. And in our case, considering areas bounded, we are saying bounded between two curves. Between, there is a curve, there's another curve. So between, it's here, in between. So it simply means we must have the area taken where the point of intersection is, from point A to another point B, where A and B are the points of intersection that we have. So our area is in between here. In between. This is the part here. Between two curves, bounded. There's another curve, bounded in between it there. So this is our case. So we are going to have the representative strip that will be definitely for X. So guys, here I'm just gonna have it like this. So this is our representative strip going down, which is for what? For X. These limits are for what? For X. They are in the X-axis. So our strip is for X. So the reason that I was presenting to say there is a function on top, there is a function below, it is this way. It is going to help us when we are to calculate now the area in between. So we're going to talk about that one later on. Let's talk about these points A and B. Because as we can see, they are needed. These are the limits. Remember, as you were referring previously, just a single function. It is the area with respect to X, the integral of Y with respect to X, we've got limits A and B. Those limits in our previous case, because it was just a single function that you were given, they were going to give you to say, all right, you are going to take this function and this region is going to be taken between point A and point B, which is X is equal to 2 or X is equal to 4. You know that it is this region that is bounded. The limits, they are already specified for you. But on this one, they are not going to specify for you. They know because they've said you are supposed to calculate the area bounded between two curves. So you know the limits are the what? The point of intersection now. That is our case. So they are not going to even ask you about, so to be told or to be given a question, calculate the point of intersection. That one, it is just a reminder, not to say you are supposed to be told about that. So those are some of the questions that I get, like if you're answering question papers, like, why is it that we are calculating point of intersection? There's no question like that. So this is the reason. The point of intersection, the points of intersection that we have here, those are your limits from A to B. So they are needed. So definitely we are supposed to calculate that. All right. So let me refer to this one. So A and B are the points. So these ones are the points of intersection. So these are the points of intersection of the two graphs. So this is what we have. So meaning to say, as we have these points of intersections, we are supposed to calculate them, unless maybe we are given maybe complicated situations where they say that for you to calculate those points of intersections, it will require a lot of marks. You remember exam, it's all about marks. So a question, when it is given, they calculate, all right, this topic is supposed to have a certain number of marks. So if we give 8 marks for someone to just calculate area and this and that, where also there are points of interest. There's okay, they can give you on that consideration. But in most cases, you are not given. You're supposed to know that this one, you're supposed to calculate them. All right. So that's your A and B. So you're gonna see how to calculate that part. This calculation, guys, is just your simultaneous equations. You can refer to your, that is mathematics, grade 11. Yes, simultaneous equations where you're given two functions, or your M3 mathematics. Yes, that part also functions. Yes, we're gonna talk about that, but you just solve those functions simultaneously. So how am I going to obtain the area that is bounded between these two curves? So it follows that the area, as we have with respect to x, it is going to be the integral of, so you subtract the top minus the bottom. So that is y1 minus y2 with respect to x. And our limits, do not forget, from A to what? From A to B, where A and B are the points of intersection of the two graphs, which has to be calculated. So that's it. So having y1, remember y1, it's a what? It's a function with respect to x. So it's just like we've got a function there that we have with respect to x. This y2 is another function. So you can just call it gx, g of x, with respect to x. The same if it was of y, they're going to consider that one of y. So these are functions. We have to write them in terms of what? In terms of x. Just like that, we are done. So like I said, to calculate the points of intersection, we are going to solve simultaneously depending with what you are given on your equations. How are they presented? But you're supposed to solve simultaneously. That is, you have got two equations where you are solving for x and y. So in our case, we just need the value of x. The limits are for x. So just calculate the x values. If you are given, they can give you a sketch. It depends. They can give you a graph which is already drawn. They write a point here, which is 2, 4. They write a point here, maybe, which is 1, 2. Know exactly what is it that you're supposed to take from those. We need the x value. So the x value there, it's 1. So that's our A. The x value there is what? Is 2. So that's our B. If you are given the points, maybe they have sketched the graph for you, and those points are given. So it is up to you. Let us consider a typical question which applies this concept where we have got two functions or two graphs. Determine, on first question, they actually asked you to determine the points of intersection. So like I said, it is not always like that, especially under exam. Under exam, they'll just ask you to sketch these graphs and shed whatever region, then calculate the area. They won't even talk about that. But if they give that consideration, then we are supposed to calculate. So determine the points of intersection of the graphs. So we have got the first one, which is our g of x, which is x squared, and our f of x, which is equal to 7x minus 10. So like I said, we are supposed to solve simultaneously. What does it mean? This is a function, a graph of y is equal to x squared. The same thing here, y is equal to 7x minus 10. So you will see that when we consider the point of intersection, we have drawn a function of y is equal to x squared and a straight line. At the point of these points of intersection, these two graphs, they are equal at that point of intersection. They have same value at this point, guys. The x value of this straight line and of our quadratic or the parabola there is the same. So knowing that these two graphs or these two functions are equal, we are simply going to equate them because they're the same. At that point of intersection, the two graphs are equal. So we equate them to say this is the y, which is equal to what? To x squared. What about this one? We have again a y which is equal to what? Which is equal to 7x minus 10. So we can equate this. The same thing to say y and y here. So it follows that the remaining part, therefore, must be equal. So therefore, we are saying x squared of this graph is supposed to be the same as the y of this graph, which is what? 7x minus 10. If y of this one is the same as the y value, it means also the x values, they are supposed to be the same at that point. So you formed an equation. That's an equation that you formed, which you have to solve for x. What type of an equation? A quadratic equation. Remember your equations. N2 mathematics, quadratic equations, supposed to be in the form of what? Ax squared plus bx plus c is equal to 0. So we are going to have x squared. Take the 7x to the other side. That was going to be a negative. All right. The negative 10 to the other side was going to be a positive. So that's equal to 0. So depending with the question that you're given, if factorization is possible, use factorization. Yeah, you can even use your quadratic formula, guys. What we need there is to have the x values. So it is up to you. Are you going to use quadratic formula or factorization? Yeah, factorization is possible. And as we can see, the coefficient of x squared is 1. So it was going to be easier for us to simply factorize because we are going to have x here and another x there. X times x, that's x squared. So for us to factorize this, we are going to consider the factors of what? Of 10, the products of 10. But these factors are supposed to add up to a negative 7. So factorization of this quadratic, like I said, check your N2 mathematics or also the videos that I've done for grade 10, grade 11 mathematics on factorization. There are different ways there that I've explained, which you can consider because it's one and the same thing, right? So the factors of 10, which will add up to minus 7. As we can see on 10, there's a 5 and a 2, which can give us something closer to this, a 7. But for us to have a negative 7, it means we must have a negative 5 and negative 2. All right, if we multiply these two, negative 5 times negative 2, that's a positive 10. Exactly what we need. But if we add, are we going to obtain a negative 7 if we add these two? Yes, that will give us a negative 7. So these are the numbers that we need, negative 5 and what? Negative 2. So that's negative 5 and negative 2. So from this, we know that each bracket must be equal to 0. So x is equal to what? You throw the minus 5 to the other side, it will be a positive. You do the same thing, throw this negative to the other side, it will be a positive 2. So these are the x values that you're going to have. Like I said, you are solving simultaneously, focusing on the x values, on the limits. These limits, guys, that we are going to have there for x. So we focus on the x value. So, okay, the x value is this one. That is our condition. But as of our question here, it is saying determine the points of intersection. So when it is like this, it is not complete. This is not a point. We have determined the value of x at the point of intersection. If it was like that, these are the values of x at the point of intersection. At those points of intersection. But what are the points now? When you consider a point, you must have the x value and the y value. So in this case, as we consider our points of intersection, all right, so let's consider our points of intersection. So it means, therefore, we are going to have the first one, when x is 5, we must have the y value. And when x is 2, we must have the y value. So where are we going to obtain these values? By substituting in any one of these two equations. Because we are saying at this point, at these points of intersection, the two graphs are equal. They're equally the same. So I can substitute in any one of these. Y is equal to x squared. When x is equal to what? When x is equal to 5, I can substitute there 5 squared, which is what? 25. So when x is 5, it means y there is going to be what? 25. The same thing, if our x is 2, we substitute a 2 here. So that's 2 squared, which is going to give us what? Which is going to give us a 4. So these are the points of what? Intersection. But what we need on our calculations, if we are to consider the areas, are the x values. But answering the question, we are supposed to answer the question, guys. The question is determine the points. All right. Anyways, let's move on to another part or another section, which is to sketch the graphs and shade the area bounded by the by the curves, which is by these two curves that we are having. So we are supposed to sketch. So remember, the graph of y is equal to x squared, just like the graph of y is equal to minus x squared. These graphs, guys, of y is equal to kx squared. You just have to consider if it is like this. This is not in the form of y is equal to ax squared plus bx plus c, where you are going to have the turning points, this and that. When it is in the form of y is equal to kx squared like this, you just have to consider to say, is our k a negative or is it a positive? So it can be y is equal to 3x squared, y is equal to minus 3x squared. The sketch of this y is equal to x squared and the sketch of y is equal to 3x squared is the same. It is the same thing, y is equal to minus x squared and this one. So you just need to know that consideration, guys, when you are given this type of a graph. When our k is a negative value less than 0, that's a negative. As we know, guys, usually in our usual consideration, we are going to have what? A said shape like this, which is opposed when it is a positive for a condition where our k is greater than 0. For positive values, we are going to have what? A smiley shape like this. So that consideration is going to be there. But the most important thing that we have on this type is that remember when you have this, our normal graph is supposed to be, when you've got a parabola, it's supposed to be in this format where it crosses the x-axis at what? At 2 points. But when on this type, guys, it is not going to be this one. It is going to be passing exactly through the origin. This point, it is going to just, not to pass, it is just going to meet this origin and it turns back. Or it can be in another way, depending with now the shape that we are given there. Is it negative or what? Positive. These are the conditions that you can only have. Where the y-axis is the axis of symmetry, which divides this graph into 2 equal parts. That will be the condition. We won't be having that condition that our graph is going to be passing through. We don't even consider that part. So in our case, this is what? Y is equal to, the g of x, which is x squared. Y is equal to x squared. It's a positive. So if it is a positive, it is going to follow which shape? A smiley one. So we are going to have our shape in this format, all right? Sorry, I just need to remove this one. So in our case, our graph was going to remain like this. We're going to have a shape like this one, positive. For this one, do not even worry to say what is going to, there is nothing, there's nothing like that. What is going to be the x, where it crosses the x-axis, it only passes at that point on the origin there, where x is what? Where x is 0. And it returns back. So if it was a negative, we're going to have it the other way. So even, guys, if it was y is equal to 2x squared, y is equal to 3x squared, it is just on the openness of the graph. So just have the same shape, because on exam, there's no comparison to say, okay, this one is of y is equal to x squared. Therefore, this one is the one for y is equal to 3x squared. You just draw. If it was y is equal to 3x squared, same shape. You just write the name of the function. So in our case, that is the g, which is y is equal to x squared. So far, we do not know which one is y1, which one is y2, because y1 and y2, I said, it must be from which graph is on top and which one is what? Below. So just a sketch. We move on to another one. F of x is what? 7x minus 10. That's a linear, a straight line. How do we sketch a straight line? Y is equal to 7x minus 10. In a normal consideration, if we are to sketch a straight line, we need the x-intercept and the y-intercept in our normal case. So we are going to consider to say, all right, according to this part, what is going to be our x-intercept? When y is equal to 0, we are considering our x-intercept. So when y is equal to 0 there, that 0 is equal to 7x minus 10. You put this one, 10 is equal to 7x divide. It was going to be 10 over 7, something like that. 10 over 7, that's like 1 comma something. All right, which is on the positive side. So like on the positive side, as you can see, guys, it has a positive gradient. Then the y-intercept, when x is 0, there we can see that y was going to be what? Negative 10. That's a negative 10 there. So x is at maybe this point corresponding down, right? Something like this, somewhere there. And the y is maybe somewhere there. So you're going to have a straight line. But in our case, we need these. They are supposed to intersect, all right, with the one that we had before. So let me do this way so that we can just have our function properly. So these two functions, they are supposed to what? To intersect. Remember, we calculated or we determined the points of what? The points of intersection. So definitely, we know that these two graphs, they are supposed to what? To intersect. So let me just start with this one, a straight line, so that it's going to be easier for us to have these two intersecting. So you're supposed to have this one intersecting. Remember, we had something like this. So something like this. All right. So what we just need is these two to show that they're intersecting. So they're going to intersect there and also intersect. That is our condition, guys. We're just going to draw. It's a sketch, guys, this one. Do not worry about much. All right. So this is y is equal to x squared. And our linear function is of y is equal to 7x minus 10. All right, so that is the condition that we're going to have. All right, so let us just say this is where we have got what? Our negative 10. This is a sketch, guys. Don't worry about much. So you were going to have a sketch like this. So it means you're supposed to know your graphs, how to sketch the graph so that you don't waste time in exam. You don't waste time. So these x-intercepts or the y-intercept, they're not even important. What is important, guys, on our presentation are the points of intersection. Remember, when you have to calculate the area, A and B, the points of intersection of the two graphs, those are the ones that are important. So when we calculated our points of intersection, remember, we determined these 5 and what? 5, 25, and 2, 4. So we need the x value, which is 5, and this one, which is what? Which is 2. So it means this one is going to be 2 as we compare our values. 2 is less than what? Is less than 5. So this value here was going to correspond with a 5. These are the limits from the points of what? Of intersection. So there's 2, there's 5. So it means the area, the part that is bounded here between these two, this part. is the one that we are talking about. So we're just going to show our representative strip, which is for what? Which is for X. These are the limits for what? For X. Just like that. So that was the consideration of our question. We had to sketch the graphs and to shed the area bounded by the what? By the curves. Then on 3, calculate the shaded area now. So for us to have the area, when it is like this, guys, we are done. Because on our area, between these, where it is bounded, which one is on top? We can see that our straight line there is on top on that region here. It is the one that is on top, the linear function. So this will be our y1, the one which is on top. So we've got y1 and our parabola, this one, y is equal to x squared. As we can see, in this region where we are talking about where in between the points of intersection, this one, it is below. So that is our y2, with the one that is on the bottom. So I said when it is like that, our area can be determined. The difference that we have between these two functions. So that was our case there. So it means we're going to determine our area. So our area, that's going to be with respect to x, is equal to the integral of y1 minus y2 with respect to x, taking our limits from a to b. So that is it. So y1 is the one that is on what? On top, which is the straight line, the one that is on top there. So that is our straight line where y is equal to what? Y is equal to 7x minus 10. So we take this part as it is in terms of x. Remember, we are supposed to integrate. We are integrating with respect to what? With respect to x. So we are supposed to have that in terms of x. So a and b, these are our limits. So we are done. So that's from 2 to 5. Then we have got y1. That's in terms of x, we said 7x minus 10. So it was going to give you 7x minus 10. This is y1 minus y2. Y2 is the one that is below, which is the quadratic, which is our x squared. So you're going to subtract x squared. So as you can see, guys, x squared is a single term. There is no need for us to even open brackets, just write minus x squared as it is like that with respect to x. We're done. So that's it. So the whole of this part here is our y1 and this is y2. Because it's a single term, there's no need for us to open brackets. But if it was the opposite, where x squared is subtracting 7x minus 10, let's say they were calculating from a certain region like that, you were going to open the brackets so that the negative affects each and every term. But here it's a single term that you are subtracting. So there's no need for those brackets. Not to say we don't need brackets there. No, it is only for this one. So no simplification. There's nothing that we can simplify. No like terms. So what does it mean? Simply integrate, right? Rewriting, guys, this to say we are going to have maybe we can rewrite starting with minus x squared. No, it is not. It is another part that we are supposed with that we can actually put aside. So guys, according to the simplification, check the graph which is on top on that region. Which one is on top? It's what? Y is equal to 7x minus 10, which is our f of x. So in our simplification here, guys, it's f of x minus what? G of x. Take note, please, there. All right, so let us integrate. Remember, as we have our integral, we need to integrate there. This is 1. So remember, you're going to add a 1. So it was going to be 7x to the exponent of 2 over 2 minus 10x minus, this is going to be x to the exponent. We add 1. So that's to the exponent of 3 over 3. And our limits from 2 up to 5. So this is what we were going to have. So simplifying, this part, what we're going to have, I just need a calculator here. So we're gonna substitute our limits, upper limit in place of 5, and in place of x, put 5 there. So that's 7, 5 to the exponent of 2 over 2 minus 10 into 5 minus 5 to the exponent of 3 over 3 like this. So this is our upper limit. In place of x, we substituted our upper limit, all right? So we are going to do the same thing to the lower limit in that case, all right? So to the lower limit, that's minus. We're going to have our lower limit, just like here, we substitute in place of x, we are substituting a 2. So that's 7 into 2 squared over 2 minus 10 into 2. All right, minus, in place of x, that's 2 to the exponent of 3 over a 3 like this. All right, so that was it. We can simplify this from our calculator. So here, let us be together because there's another part that I need to explain. All right, so with my decimals to 3 decimal places, because I fixed my calculator to 3 decimal places, so I'm just gonna have my answers to 3 decimal places, which is not a problem. 7 into 5 to the exponent of 2 over what? Over 2. We move aside minus 10 into, open a bracket, that's a 5, close it, minus, just gonna put a fraction, 5 to the exponent of 3 over what? Over 3. So this was going to give us negative 25 over 6. Or you can have it as a decimal if you want, negative 4,167. Negative 4,167 minus the area that we are going to have there. In our simplification, like not the area, like the value that we're going to have here. So we're going to substitute a 2 this time in place of the 5 that we had. Just going to put a 2 there. All right, so this is what we're going to have. Let us put a 2 and a 2 here. This was 7x and now 7x, all right? No problem. That's a 2. And this one, a 2 here. So we're going to have a 2 there. So this is what you're going to have. And that's a negative. That's negative 8,667 like that. All right. So this is going to give us negative 8,667. All right. So as we can see from this interpretation that we are having at the end, we are going to have negative here, which is what? Positive, or you can just have it, this one on your calculator. Negative 4,167 plus 8, it's gonna be plus that one, 8,667 like this. All right, so this is going to give us what? 4,5 according to our simplification. So that's 4,5 square units that we are going to have at the end. So this is how sometimes we can have our areas, or when we are to calculate the area which is between the two functions or between the two graphs, we have to consider to say which of the two graphs that we are having there is on top on that particular region where we have the points of what? In between, the points of intersection, in between. Which one is on top? Which one is below? So the one on top minus the one that is below, you integrate, you substitute your limits as usual. So by substituting these limits at the end, we are going to determine the numerical value for our area. So we just need to work as much questions as we can. So we're going to consider in our next class working with typical questions, more exercises. So make sure that you become part of the family, join the membership so that you don't miss any of the other classes that we are going to have till we meet again.